In this video, I will show you how to use the electric field to calculate an electric force. Let's say that at this location right here, we have the electric field, and let's say that the electric field is pointing to the right and it is the vector 80,0,0 newtons per coulomb. This is the electric field at that location. Now, let's say that I have a number of different charges, Q1, Q2, Q3, Q4, and so on, for which I want to find the electric force acting on them once I place those charges at that location. The usefulness of the electric field concept is that we can easily calculate the electric force for all of these charges if we bring them at that location, because the relationship between the electric force and the electric field is F equals Q times E. Once you have the electric field for a particular point in space, you can multiply that electric field with any charge Q to find the force acting on this charge. For example, let's say that I want to bring charge Q2 at that location. To find the force, the electric force acting on charge Q2, I will need to multiply the charge Q2 with the electric field. So I need to do 5.1 times 10 to minus 9 coulombs times the electric field vector, which is 80, 0, 0. And to do this calculation, since this is a scalar and this is a vector, I need to multiply this number with every component of the vector. And the electric force then becomes 4.1 times 10 minus 7 0 newtons. This is the electric force that acts on charge Q2 if you bring charge Q2 at this location. Now, if you want to find the electric force that acts on charge Q3 if you bring at this point charge Q3, then you would just have to change. Instead of Q2, you will need to use the value for Q3. And this is how you can use the electric field concept to find the force that is acting on a charge at that point in space.